All right. Also, make sure you have this little piece of paper. Does anybody not have this little piece of paper? All right. Let me get a pass out. Jordan, find a seat. Okay. There you go. It doesn't matter. All right. I'm just gonna pass them around. Y'all just kind of circulate them and pass the song around. Because you know, in the theater, gotta have a song. All right. Yesterday, Chance. Yesterday, we did a Nearpod, and we learned about how the theories of the atom have what over time? Move. Not really move, but what did they do over time? Change. The way the thoughts of the atom and how it came to be and everything in it, how it's changed over time. Yes? Yes? Well, today, you're going to have a little show about the modern theory of the atom and a model of what it looks like. Okay, so here on the ground we have our city of Matterville. Okay, so this is Matterville. All right, and in Matterville we have some family members. Okay, members of the Addams family. Get it? Okay, come on, y'all a little slow this afternoon. Addams family with a T. Addams, right? Okay. And in this Addams family, we have two sisters. They're really large. Okay? Big and fat, and they're large. The first one, she's really happy and perky and positive. She's always smiling, her eyes are sparkling, and she's just always giving positive comments to everyone. Okay? Her name is Positive Patty Proton. Okay, Positive Patty Proton. Would y'all like to meet her? No. Yes. All right, so come on out, Positive Patty Proton.
Come on out, Positive Patty Proton.
Come on. She heard you. How are y'all? I am Positive Patty Proton. It is so nice to meet you. Are you happy to be here? I am Positive. It is so glad to meet you. I just love PPP. Are you positive? I am positively happy to be here. It is good to be here at the junior high, and we are positive people. Positive, Jeffrey. Yes, we are positively happy to be here at Azle Junior High. Are you positive? Yes. Oh, right. I am excited. Now, she loves to spend her day playing video games in the Nucleus Arcade.
Where? Video games.
The Nucleus Arcade. Okay, and she just sits there and she plays her game in the Nucleus Arcade, and she gets real big and fat because that's all she does. She stays in the Nucleus.
I am perfectly fine.
She's very perky and positive. All right? So, we're going to draw her. So, if you will, oops, let's get rid of this. Where are the tools? There they are. All right, if you will, we're going to name her. So, what was her name again, Elijah? She's
Positive. Patty
Proton. Okay, and when you write Positive Patty Proton, we're going to put a plus symbol by her because she's always positive and happy. Okay? What does she look like? Who can give her a description? And you're doing this on your paper with me. What does she look like? Okay, she's large. That's right, large. She's large. What else is she? Always very
Hyper.
happy. Let's call it
Energetic.
positive. She's very positive and happy. Okay? Alright, her eyes, they sparkle like stars. So what could we draw to symbolize her sparkly, happy eyes?
Stars.
Not stars, but we're going to give her two positive eyes. Okay, so you're going to draw two positive eyes in her face. What about her mouth?
Like that.
Jordan, tell me about her mouth. How can we draw her mouth? Pink. A big smile, because she's always what?
You're my favorite, so
She's always positive. And what is her favorite activity? Where does she like to hang out?
The nucleus.
The Nucleus Arcade. So she hangs out
Arcade.
in the Nucleus
Y'all got crazy.
Arcade. Alright? She is Positive Patty Proton. Alright, everybody got that down?
Yeah.
She has a friend. I mean, she has a sister. Somebody that likes to come and hang out with her. She's large, too. They're the same size. Okay, and she comes and she hangs out and she sits in the the arcade all day too. And here she is right here. Her name is Neutral Nerdy Nelda Neutron.
Hello.
Nerdy, Neutral Nerdy Nelda Neutron. She's very boring. She doesn't have any fun.
Y'all in class? Is anybody here? Are y'all in class? Class is boring, isn't it?
No, it's not boring.
I got a bunch of neutrons in here. They're all boring.
Oh, that's right.
Nerdy Nelda Neutral.
Maybe you can teach them something, Nerdy Nelda. See, she's just as big as Patty Proton.
I like my groceries. We like our groceries.
That's right.
How you doing, Patty?
I'm great.
Oh my
Positively.
gosh, she
Oh,
does
she's
amazing. She's so positive all the time. Not me, I just like to sit on the couch. She plays that Wii where she's moving around and happy all the time. I just like sitting on the couch and just vegging and chilling and playing my Mario Brothers. It's not moving.
I think that leg broke his.
Okay. What are y'all doing? I know y'all are in
They're
class, so y'all
waiting for
what are y'all
you to
doing,
educate
Jeffrey? Oh, they're drawing pictures. They got a
They
picture
drew
of
that
me.
positively perfect picture.
They didn't draw a picture of me. Do y'all want to draw a picture of me? Huh? Let's draw a picture of me. What's my name?
I don't know.
Ew, I know.
Negative Nelda.
I am not negative. What am I?
A neutron.
What am I, Jeffrey?
A neutron.
And what charge am I?
Negative.
I'm not negative.
You're positive.
I'm neutral.
I'm positive, Jeffrey.
She's positive. Look
That's
on
weird,
your
y'all know my name.
stories. It's sitting in front of you. Y'all need to borrow my glasses.
Yeah.
What does it say about Nelda? She's what?
Now,
Neutral.
Oh, neutral.
neutral.
What else am I? And I'm
Nerdy.
proud.
Nelda.
Nerdy.
Nerdy.
What's my name?
Nelda.
And what am I? I'm a neutron. How would you describe me?
Loud.
Nerdy. Nerdy. What else?
Fat. Fat.
I'm not negative. What am I?
You're neutral.
Y'all learn this.
You're neutral.
Listen. This is a good learning point, okay? Because this is what you're going to have a tendency to do on the test. When you hear neutron, you're going to automatically want to put, because it starts with an N, what are you going to want to put with
Negative.
that? Negative. I am not negative, okay? Nelda Neutron is not negative. She is what?
Neutral.
Neutral. If you will remember, neutral, neutron, they're spelled alike. Don't get those mixed up. Nelda Neutron is not negative. What is she?
Neutral.
Everybody together, what is she?
Neutral.
Neutral. Okay? So in our description, we're going to put big capital letters. Nelda is neutral. Okay? You're going to have to remember that. It's a very common mistake. I am not negative. What's my favorite activity?
Same as hers.
Playing the
What is hers?
Playing Mario's, chilling on the
Playing video games where?
Our nucleus arcade.
In the Nucleus Arcade.
Nucleus arcade. Arcade. Ooh. Oh yeah.
Okay? What do you think my eyes look like?
Big. Circle.
Very good. Circles. Once again, class, what charge does a neutron have?
Neutral.
Neutral. What do you think those zeros stand for?
Zero. Neutral.
Neutral, zero charge. That's why I have zeros for my eyes. Zero charge. What do you think my mouth looks like?
Frowning.
We're not sad. I'm not
Negative.
negative. What am I?
Straight line.
Just a straight line.
What about her nose?
Boring. Okay? All together, once again, what charge does a neutron have?
Neutral.
Very good. Remember that. Okay? All right, we're going to move on in the story. I'm going to have to borrow yours, Ariel. All right. Around the nucleus arcade, where Patty, positive Patty proton, and neutral Nil the neutron, where they hang out, there's a bunch of roadways. Now, we looked at these yesterday when we looked at the atom. This was in Bohr's model. Does anybody remember what those rings, those circles around?
Levels. Train tracks.
Clouds.
What kind of levels?
Focus on clouds.
No. You're close. Yeah. Go ahead, Cheyenne. Cheat. Good job. Cheyenne's cheating. What's she going back to?
No.
Her notes were, what are they called, Bailey? Shells. Okay? I always want you to cheat in my class. Go look at your notes. Go find out what they're called. Okay? These are energy levels. Okay? And around these energy levels, they're called roadways for today. We have another member of our family, negative Elliott electron. And negative Elliott electron rides his bright red chrome-plated Harley-Davidson around the nucleus arcade. He rides so fast that sometimes we don't even know where he is.
Hi! How you
What
doing,
up, Elliot?
Elliot is much smaller than Patty and Nelda, but Elliot is always angry and negative. He's angry and negative because we, me and Positive Patty Proton, won't let him in the nucleus arcade. So he has to stay outside and ride his motorcycle. Okay? Around.
She's mad. She looks mad.
She's always mad. Oh, let's draw a picture of Elliot.
I want to play in the nucleus. This stinks. It's not fair.
Elliot can never get in the nucleus. Only positive Patty Proton and neutral Nelda neutron can get in the nucleus. Okay? Alright. Who are we going to draw a picture of now?
Her.
Who is her?
Elliott electron.
Elliot.
What am I? Very
Negative.
Negative.
Yes, you are.
Very negative.
Yes,
Yeah.
you are.
Negative Elliot electron. How would we describe negative Elliot electron? What kind of personality, Tommy?
Negative.
Angry.
Mad.
Mad. What else? What's another good term? What kind of charge?
Negative.
Negative.
Skinny.
Oh, very good, Bailey.
That was Gracie.
We're going to use small.
Yes.
Elliot is small. By the way, did y'all put on what I am?
Large.
Oh, yeah,
Extra
Nelda's
large.
large. She's neutral and large. Patty's positive and large. Okay? What is Elliot's favorite activity?
Riding the
Woohoo! Riding the motorcycle where?
outside the nucleus.
Outside, around the nucleus. Very good.
Oh, you like to ride on those energy highways.
Ride it around.
Ride around that nucleus because they won't let me in.
Not in my.
What do you think Elliot's eyes look like?
Mad.
Let's think about the charge.
Negative.
Negative. So two straight lines are negative sign. What do you think Elliot's mouth looks like? He's the one that's not ever happy and
Frowny face.
Frowny face. your drawings, let's look at the eyes one more time. Tell me what the charge of a proton is.
Positive.
Positive, Patty, proton. What is the charge of a neutron?
Neutral.
Neutral. And what is the charge of an electron? Negative. Okay, remember that. All right, flip your papers over to the back.
Oh, sweet. Okay. One.
All right, on the back, you have a drawing at the top. I want you to ignore that for a second, and I want you to draw your own picture at the bottom here. So go ahead and start drawing what you see up here as closely as you can as we're talking. So you probably start with the thing in the middle. Okay, what do you notice about in the middle, Colton? You're drawing that right there at the bottom of your page. You're drawing it. No, Jonathan, on the bottom. No, don't write on the target that's there yet. I want you to draw your own at the bottom.
Done.
All right, so Colton, what's in the middle? Right there in the middle. Protons and neutrons. So you need to put those in the middle. What's next to the word proton? No, what's next to the word proton? Positive sign. Okay. What's next to the word neutron? No, not negative.
Neutral.
Okay. And what is that middle part called up there, Madison? Nucleus. Very good. Okay, make sure you have that all labeled in the middle. Now, I see two more. What are those things, those circles around it called again?
Highways.
Not highways. We're going to call them what they're really called. Shells or? It's labeled?
Energy levels.
Energy levels. Okay, so you have your nucleus. Don't get confused. This first one is part of the nucleus, and then this is the two energy levels out here. Okay? What are on these outer energy levels? What are those things called?
Negative.
They're negative what?
Neutron.
No?
Electrons.
Electrons. Me and my brother. We're on those shells, okay? And they're labeled energy levels. Who remembers from yesterday? There's a V word up there. What do we call those outermost electrons? They're called the, somebody said it? Valence. Okay, those are on the outermost shell. Those are electrons on that last shell. Okay? Chance, what does each one of those electrons have in its inside of them? What's the symbol inside of all of those electrons?
Negative.
Negative. Okay, so now
If
that
y'all
you...
will notice, I don't mean to interrupt.
No.
He's called these atoms. You are actually making a drawing of an atom. This whole thing represents an atom. Okay? So you're actually drawing an atom. Not the little individual things are atoms. This whole thing is an atom.
Okay.
Okay? This is the structure of an atom.
All right, so now that you've drawn your picture at the bottom, we're going to start labeling that pre-made Matterville picture at the top. All right, so there's 4 lines we're going to fill in. So that first line is pointing to the very center. What did Madison call that? Nucleus. So up there at the top, I'd like you to write the word nucleus. And what does it contain?
One in
It says it right there. Proton,
Y'all are going back up to
and
Matterville. You're going to label
neutron.
the top drawing.
Yep, we're at the top. We're in the Matterville drawing now. You did your drawing at the bottom, and now we're just going to fill in at the top. Right here, Cheyenne, right? We're filling in the first one. Okay? We're filling it in up at the top. All right, the nucleus contains the protons and the neutrons, all right? Now the second arrow is pointing to that, one of those energy levels. What can we call that? It's the very first. Okay, that's what we're going to call it, the first energy level. So go ahead on that second blank. We're going to write first energy level. Okay? The word energy level's up there if you need help spelling that word, energy level. Now, tell me what's special about it, Tommy. How many electrons can it hold? It can only hold 2. Now, knowing that, go back and look at your drawing because I think some of you might have put too many on your first energy level. So go back and look at your drawing. Make sure you only drew 2. All right? So if that first one's called first, what do you think the next one's called? Second. Go ahead and label it. Second energy level. And how many can it hold, Jordan? Where'd you figure that out? Right there. It says can hold 8 electrons. All right? So make sure to go back. Because, Tommy, I think I see way more than 8 on your second level. All right? So go back and count. How many did you draw on your second one? Okay, which is why we said bring a pencil. All right? So if you drew more than 8, go back and fix it. All right? So then what do you think the next one's called? Third. Go ahead and write third energy level. Okay? First energy level, second, and then third. Okay? And on that outermost level, you do find the valence. How many can it hold?
18.
Alyssa? 18. All right, it can hold 18. All right. Did I cover it all?
Yes.
All right. All right, so if you will, we're going to take a picture because we haven't done that, have we?
No.
We have not done a picture. Quickly, we're going to do a picture. Okay? So you make sure they're labeled, Blake. Can you see it? Are you sure? You didn't label
Don't
it?
get your iPads out. If you don't have your iPads, you need your phone.
Picture. Okay. Gonna take a picture of where we belong on our drawing here.
We're going to let y'all take a picture so when you go to study for your 6 weeks test, you can actually pull this up because you're going to have to know the location of each of us. We learned this yesterday in our Nearpod. We are what they call the subatomic particles. Y'all remember this yesterday? Okay. Remember, each one of them was discovered at different times. We discovered, what was the first one that was discovered? Do y'all remember?
No. Photon.
Very first one
Say Jesus in me.
was the electron. And what was discovered next?
Neutron.
The proton and, no,
The nucleus.
the proton and the nucleus. So what came last?
Stop.
The neutron. Okay? And we are all three the subatomic particles. Okay? Y'all can come take a picture of it. Make sure you get the energy level so you can see, so when you study for your test, you know where each one of these goes. Paparazzi's here. There we go.
All right.
Harley Davidson.
You need to get straight on, Jeffrey, so you can see the charges that go with what they need. You're going to use it to study with.
All right, let you get a picture.
Miss Thompson yet.
Have a seat. Yes, I'm on the outer energy levels.
Did you get it, Jeffrey?
Mad. If you will, after you get your picture, if you will find your periodic table from yesterday.
Jeffrey still needs to figure
Oh, Jeffrey.
Come on, Jeffrey.
All right, turn to your periodic table, which should be glued into the front of your journal. Okay, if you weren't here yesterday, go grab one from the back. Okay, have that open because we're going to be using that while we also start a new note page. We're just going to do a drawing. We're not going to take a lot of notes, we're just going to do a drawing. So have it open, but also flip to a new page in your journal. Okay, so right past your notes from yesterday. And we're going to label this page element card. Element card. And you're going to draw yourself a nice big rectangle, not as big as your page, but pretty big because we're going to write inside of it. All right? Which one should we do? Should we do the same or different? Lithium. Okay. All right. If somebody will, after you get this drawn on a new page, element card, we're looking for the element lithium. Okay, so who can find it? It's on the left side. Who can find it and tell me what its letters are? Tommy?
If you don't already, you need to have your periodic table opened up. It's in the front of your journal. You glued them in yesterday. Open up that periodic table. You're going to be using it.
All right. Tommy said Li for lithium. So what do you notice about these periodic tables? They're either all, what? What about all these letters? Tell me about them.
They're all,
What kind?
they're all consonants.
Well, not consonants. They're all capitals or a capital and a lower. Okay? All right, lithium. All right, so lithium stands for this is actually our element name. So this is the name of our element. So we're going to label these parts. And if you will notice on your periodic table, there's one done for you as an example. What's that one that's done for you on your periodic? Right? It's smack in the middle. Starts with an S. Silicon. All right? All right, so
Hang
element.
on. I'm going to switch something.
Oh, thank you.
Here.
That's just
I need a
the,
pen. This is called
symbol.
the element symbol.
that's the element symbol. So if you wrote name, erase that. Oops. Element symbol. Okay? Because it stands for the element. Now, Tommy, what is the element name?
Lithium.
Lithium. So she's going to spell lithium at the bottom. Okay? So now label that element name. Oops, we've done this a lot of times today. Probably Electron. He has a headache from all his negative faces. Okay, so that's the
I got it
element
this time.
name.
I got it.
You got it? Yeah.
Next, I want you to look at, there is a number number right above that element symbol. Can somebody tell me what that number is? Jeffrey?
3.
3. This is what we call the atomic number. Okay? And then we have one more number under there. Who can tell me that other number?
6,941.
Oh, let's look again.
6,000. 6 and. Oh, 6 point.
There we go. 6 point what?
941.
941. This is what we call the atomic mass. Okay? Now, when we're looking at these, you also have a diagram on the top of your periodic table. Remember, you're going to have this on your STAR test. So if you forget what something is, you can always go back to this. And on your reference material there, up in the middle of your periodic table, is silicon. And it's actually labeled for you. Okay? But we're going to break it down even more. The atomic number actually represents how many protons and how many electrons we have in this element. Okay? Each one of these elements is represented by an atom because atoms make up everything on that periodic table. Okay? Atoms make up every element. So do we have different atoms represented on the periodic table?
Yes.
Yes. A whole bunch of them. How many's on your periodic table?
Who's on there?
100 and how many? 102. There's actually more. There's actually been some added to that. We're actually up to like 113 now. Okay? Does it have 118?
Yes. I don't know.
Okay, so we're up to 118. Okay? Alright, so the atomic number tells me how many protons and electrons are in it. So if you're looking at this element card, how many protons are there in lithium?
3.
3. Okay? Are y'all following me? My atomic number tells me how many protons and electrons are in lithium. So, how many protons are in lithium? 3. How many electrons are in lithium? 3. Okay? Yesterday, when we were taking notes, Chadwick introduced a new term to us called atomic mass unit, better known in what we're going to call AMUs. Okay? That tells us the mass of each one of these subatomic particles, the neutron, the proton, and the electron. Okay? The proton, one proton, equals 1 atomic mass unit.
You can write that anywhere.
Okay.
Underneath it, beside it,
Somewhere on your
1
element
proton
card.
equals 1 AMU.
Now, believe it or not, me and Patty have the same mass. So what do you think my atomic mass unit is? 1 atomic mass unit. So 1 neutron equals 1 atomic mass unit. Okay? Now, don't get this confused. It doesn't have anything to do with grams. It is telling us the mass of this element, but it is represented by atomic mass units. Okay? Now, what about negative Elliott electron? Is he as big as we are?
No.
No. What do you think his might be?
0.5.
Good guess. Okay?
I'm smaller.
Small. We actually don't know that. So what we use to represent the electron is 1 electron equals less than 1 atomic mass unit. The proton and the neutron are both a lot bigger, actually have more mass than Elliott. Who can tell me what mass is? Cheyenne?
How big an object is? Or how much space is it?
Not how much space, that's volume.
Any
How
object?
much stuff?
Come on. Oh, Jeffrey.
Tell me, Jeffrey.
How much stuff what? Jeffrey, come on.
Something we did.
How much stuff, how much matter is in an object, okay? How much stuff it's made of. So, for me and Patty, the stuff that we're made of is 1 atomic mass unit, okay? Now, I'm gonna show you an example of this one, okay? I have my, oh, we gotta sing.
We'll sing and then we'll make it, because just in case we...
We got till 2:45? Okay, yeah, we'll sing to it one time.
She has
Get
a
out your
little
Adams
song.
Family song.
I know, you want to sing.
Oh,
And if you
everybody
don't
wants to
sing, we're going to
sing.
have you come up to the front and sing, Jordan. We're going to sing it quick, too.
All right, do y'all remember the show? Most of you have probably seen this, or your parents have. The Addams Family. Da-da-da-da. Da-da-da-da. Da-da-da-da-da-da-da-da. Y'all remember that? We're going to use that chorus to sing to. I'm going to sing verse 1 for you. Then I'm going to let you join me on the second verse so you kind of know how it goes. Okay? All right. They're teeny and they're tiny, much smaller than a beanie. They never can be seeny. The Addams Family. They are so small.
Down to the chorus.
They're round like a ball. They make up the air. They're everywhere. Can't see them at all. Are y'all ready to join me on verse 2? All right, everybody in. Come on, everybody can sing. Everybody's done it all day. All right, here we go. Second verse. Together they make gases and liquid like molasses and all the solid masses. The Addams Family. They are so small.
I think they want to sing it again.
They're round like a ball.
Because they're not singing
They make
at
up the
all.
air. They're everywhere.
Can see them
At all. Okay, I am not singing by myself. You guys, I'm going to make you sing one
You
at a
are not
time
too
if you
cool
don't
to
sing
sing. You are
with
still
me.
kids.
Okay?
Let's go.
So I want everybody to hear singing verse 3.
Come on, you're the first ones that aren't singing.
Alright.
Come on, ready?
All right, here we go. Neutrons can be found.
Where protons
Just hang around. Electrons they surround. The Addams Family. They're so small. They're round like a ball. They make up the air. They're everywhere. Can't see them at all. Okay, this is not acceptable for me. So we're going to go back and we're going to go through the whole thing and everybody's going to sing. And if you don't sing with me and I'm watching, you will come up and sing it by yourself.
Come on, guys, just sing
So I want
it.
everybody singing
If everybody's
with me.
doing it.
All right?
Let's go.
So, here we go. They're teeny and they're tiny, much smaller than a beanie. They never can be seeny. The Addams Family. They're so small. They're round like a ball. They make up the air. They're everywhere. Can't see them at all.
Come on.
Together they make gases and liquid like molasses and all the solid masses. The Addams Family. They are so small.
Uh-oh.
They're round like a ball.
I'm trying to check.
They make up the air. They're everywhere. Can't see them at all.
Oh, going too fast.
Neutrons can be found where protons hang around. Electrons they surround. The Addams Family. They are so small. They're round like a ball. They make up the air. They're everywhere. Can't see them at all. Most of you can give yourself a hand. Very good.
Bravo.
You can
Y'all did good.
kiss it.
Okay, we're going to do this quick.
Okay, I'm going to use.
I hate singing.
Y'all told me that each proton has an atomic mass unit of 1. So I'm going to use golf balls to represent my protons. Okay? Neon color. Daddy's
bright,
happy, so I'm
positive.
going to use bright, positive. Okay?
Yep.
I'm going to use ping pong balls to represent the electrons because you told me that the mass of an electron is less than 1 atomic mass unit. So, Gracie, I want you to hold those and tell me the difference in mass. Do they have different masses?
Yes.
How do you know that?
Because this one's heavier.
So that one's heavier, which means probably what?
It's more dense.
Not more dense, but it's got more stuff in it. Okay? What do we know about ping pong balls?
They're just thin plastic.
They're hollow. Okay? Golf balls are full of stuff. It's actually a bunch of like rubber bands round up in there. So there's a whole bunch of stuff in it. Okay? Whoop.
You lost my brother!
Okay, so I'm going to use golf balls. Okay? Neon yellow, these are my protons. How many protons do I have in lithium?
3.
3.
Good.
Okay? These go in the nucleus. So I'm going to put these in the nucleus. Okay? Now, how many electrons do I have in lithium?
3.
Good.
3.
All right, go ahead and put them all in there.
Okay, I'm just going to put them out here?
What do y'all think? Out on that outer one?
No.
Where?
What?
Middle one? You mean
What's in the
the
outer
In the
shell?
nucleus.
in the nucleus?
Yeah,
it's
my
the
electrons go in the
make 'em
nucleus?
explode.
Where do they go? Look at your drawing. Where should we put them first?
What?
They go
Right there
on the
with
outside.
the neon green
Okay, they go on
ones.
the outside of the
The
nucleus.
second level.
They go in the second level.
They go on the first energy level.
I've got to start with my first energy level.
How many?
How many can I put on there?
Two.
2. Okay, so there's 1,
Oh, roll
and
in
here
there.
is 2.
All right.
Now,
Now what? Where does 3
where
go?
does the next one go?
Out on the outer one.
outer level.
But you need
On the second
7 more.
energy level.
You need 7 more.
No, I don't.
7. That's the total.
This
Most
is
it can
3.
have.
I'm building lithium.
How many does it have?
Okay, my atomic number
Oh.
tells me I have 3 protons and 3 electrons. I have 3 protons and 3 electrons. What am I missing?
Uh-oh, who are we missing? Nerdy? Nelda?
Neutrons.
We
I'm
need
missing
some
the neutrons.
Well, how many?
Is there anything on my card that tells me
No.
how many neutrons I have?
No.
Yes. Yes.
What
Yeah.
number?
The one of mass.
That tells me the mass. That tells me how
No.
much is in my nucleus.
You don't.
This does not tell me how many neutrons I have.
Listen, y'all are
There is
figuring it out.
nothing on my card that tells me how many neutrons that I have. So I'm going to teach you a formula.
Watch. We only got a couple
Okay.
seconds.
One.
We're going to round off our atomic mass to the nearest whole number. So if I round off 6.941, what's the nearest whole number?
7.
7. I'm going to take my atomic mass and I'm going to subtract out my atomic number. So I have 7 minus 3 is
4.
4. So I have 4 neutrons in lithium.
Where'd they go? Where'd they go?
On the outer side.
Oh, where the neutrons in the nucleus.
Okay?
4.
So there are my 4 neutrons. We have just built a model of the atom lithium. Okay? Now, I'm going to do something and I want you to tell me.
What you do wrong? Here.
Oh, girlfriend.
Here.
Listen.
Okay. I'm adding 2 more protons. I'm adding 2 more neutrons, so there's 7. And I'm adding.
You do like 7.
I'm going to have to use a white. I'm adding 1. Oh,
Right,
I'll finish tomorrow. I'll do this tomorrow.
Leave your added song on your desk and go
Heavy.
fold this piece
Fold
of
up.
paper. We're gonna have to